All right, good morning and happy Tuesday. It's July 25th, and I'm planning on doing the contest from last Saturday, weekly contest 355. So let me share my screen. We'll start jamming. All right, here we go. Okay, weekly contest 355 virtually. Okay, here we go. Open these guys up. Separator, basically split on the separator. Okay, kind of silly. X will be our separator. How about return a dot split X? Kind of silly, right? Easy problem. Oh, we need to remove the empties as well. Oh, for each of those, return s dot split X. Oops. Or S and A. One, two, three, four, five, six. But then we do need to flatten them. Yeah, flatten that and remove the filter the empties. Okay. Flatten. Let's see, and then we need to filter it as well. Turn A dot S if or S and A if length of S, something like that, right? Oh, flatten, really? I thought there was a flatten function. I thought flatten. Huh, that's strange. Let's just do this in JavaScript real quick. Oops, split. Okay, words and separator. A delim, right? Delimiter. A equals A map string split based on the delim. Just X will be our split on fine, right? Filter S style length. Okay, and that would be pretty much, oh, and then use low dash to flatten it. The filter flatten. Okay, I think that works. And something like that. 1, 2, 3, 4, 5, 6. Easy problem. That's the filter not working. Flatten and then do the filter. Looks good. Okay, that's cool. That's 8:18. About 3 minutes, 30 seconds. That's cool. So 3 minutes, 30 seconds for Q1. I'm pretty sure there's a flatten function. Python 3 flatten. Or, oh, actually, we do list comprehension, right? Flatten extend? Flatten concatenation. Oh, okay. Yeah, okay. So we can do the flatten ourselves, basically. All right, so let's do that. Each word, the word is split. desktop length. So S in A or S in A. Looks good. Yeah, so we just flatten it ourselves. Right. So see if we can stick this on one line. I think so. I just stick this here. Yeah, that looks good. Okay, so that's cool. All right, and then let's just do this guy, lambda a max, and then we'll just return this guy. Right, so use list comprehension to do the flatten. Oops. So looks good. Okay, all right, that's cool. The XBR delimiter, right? View solutions. Flatten the split strings S of the input, oops, input array. Non-empty. Yeah, that sounds good. Non-empty array. Kotlin. JavaScript. 3. Rust. C++. Okay, so this one's Python 3. Okay. Given limiter X. Flatten the input array A. Right, flatten the input array A with the non-empty split strings S. Strings S. Split with delimiter X. Okay, yeah, that sounds good. All right, that one, this guy, I had to take 3 minutes, 30 seconds, not too shabby. Okay, let's do Kotlin. Let's keep going. That'd be cool if we can get to the end here. The end would be Q4. Map each value. It dot split on the character X. Dot flatten. Dot filter. It dot length exceeds 0. Something like that. Looks good. It's cool. Let's change this into a one-liner using a lambda. Okay, something like that. Looks good. All right, that's cool. Okay, rest in C++, and we'll move on. a dot map into iter map each string. Does rest have a split function? I don't know. So string split. Harry, no more. Oh, okay. Yeah, there is. Okay. S dot split on X, check the limiter. Dot flatten. Dot filter string such that string length is non-empty. That collects into a vector of string. So I'll shorten these things up a little bit. It's not so verbose. To a vector string, which will return. Okay, something like that. Reference to string. Split. It's not split, returns a. Oh, I see. Split. Filter. Map. String. Promise. Something like that. The reference to data owned by the current function. Oh crap. What's split do here? Split remainder. Next. Oh, okay. So split is kind of like an iterator into iter. I wonder if we can do this. Do the mapping to a string here from split. Turns of value referencing the data owned. Iter is borrowed. Method iter for split. Oh crap. Next. Let's see if we can find this at rest string split example. I don't really know Rust very well. Let's put a string in Rust, right? Split. These are our parts. And collect into vector of okay, so to string in Rust. Is it two string? Oops, hold on. Two string. Oh, a slice into okay. So slice into a string dot map. Select into a vector of strings, which will flatten, filter, and collect again. Yay, that looks good. Woohoo! Okay, yeah, Rust always gives me a hard time, it seems. It's like, man, even the basic things are kind of hard. Okay, you have to split it into string references, collecting a vector of strings, flatten it, and filter it. I wonder if we can filter it. Oh. Yeah, it's okay, whatever. Yeah. Okay, do C++ and move on. Right, we're still on question one, right? So Let's go. Come on. All right, vector string. It's got to just start delimiter. Array of words. Okay. And I don't think there's any white spaces there. Exclude empty strings. That makes sense. Okay. So each string, the input array A. What we'll do is we will transform the string inline character equals our delimiter. Then it'll be character, otherwise white space. Whichever one occurs more often would probably be the non-delimiter, right? Which is be a neutral character. Okay, so there's our map function in the STL. And then we can use a string stream. Or wait, hold on. The stuff in for each string. Oh, okay. All right, let's do this. Here's our answer. We're trying our answer at the end here. Oops, return answer. My string stream, input string on S file. For word, and then sort of push back word. That sounds good. Oh, X cannot be implicitly captured by the lambda. That's true. Or copied by value. Looks good. Okay, that's cool. And actually, I'm thinking this can be cleaned up a little bit. Just copy, right? Copy the stream iterator. All right, let's just do this. Nice stream iterator. All right. I think that's more STO version of doing the same thing, right? It's a little bit more verbose. So let's do this using iter equals this guy. We'll just call it iter. Make it a little bit less verbose. Okay, something like that. Looks good. Good enough. I just stick it on one line as if it's a atomic operation. Right, okay, that's cool. All right, yeah, that would make a linter light up like Dwally, right? But for the case, the context of algorithms, I think it's okay, right? In production code, I definitely do things significantly different, right? This kind of includes the namespace. I guess it's within solution, but yeah, a lot of things I would not do exactly like this in real production code. Right? So that definitely belongs on a new line, but here we can just say, hey, we're just copying the contents of this string that we can split on the delimiter, right? It's kind of like that. Yeah, ephemeral value, right? But okay, here we go. So flatten the input array A with non-empty strings S split with the delimiter X. Right, there we go. Okay, Q1 down. Beat that up really good in 20 minutes. Okay, 1 hour, 10 minutes left on Q2. Q2. 1 hour, 10 minutes. I'm gonna grab a kombucha real quick. Yeah, I'll be right back. Okay, array of numbers. Here we go. If it's less than or equal to its adjacent by, replace this guy with that plus that guy and then delete that one. Okay, so you can kind of like merge, right? So this one's less than that one. This one's less than that one. Oh, we're gonna want to merge right the small ones, and then you can get it big enough to merge that one. Merge. Choose I equals 0, it's 5. Choose I equals 1. Oh, I see. Okay, I think this does look like greedy offhand. Two, 3, 7, 9, 3. Left to right, we can reduce these to 5, 7, right? 3. Now either we can take 12 or we can take 16. Right here we can take 5. Still better than this one. Or monotonic. I wonder monotonic Q. Yeah. No, that doesn't work because here, right, we can, here we have two choices. Two choices. Either consume 12 or 16, right? So consume 16. Wonder question. Oops, questino. Right. What if we reduce from right to left instead of left to right? That work? Can't reduce 3, but it seems like that would make the thing on the right the biggest, which is what we want. So what if we reduce this in this order? We do 16. And 2, and then we do 19, right? And then 21. That makes life easier. Okay, that'll be the game plan. We'll go from right to left. Does that work with this one? Yeah, it works with that one. Okay. So right to left, 4i in reversed. Range, length of A. It's -1, because we can't take that rightmost one. There's nothing to the right of it. Okay, so if a sub I is less than or equal to a sub I plus 1, that's the constraint to the problem statement, then we can stick that there. Do it instead of left to right, right to left, right? So a sub I plus equals a sub I plus 1. Okay, and then we'll have some total that we'll keep track of. T equals 0, return our total at the end here. Oops, return t plus equals a sub I. atomic operation. So the code lines up. Okay, so it should be 21 and 11. Oh, 56 and 17. Six and 17. What the? Doesn't go there. This plugs into that, so that's 16. Oh, I see. Okay, so okay, it's overlapping the way that I'm adding it up. Keep track of last. We can subtract out of it. A sub I plus 1, 16. Let's do this. Okay, is a set. Okay, dot add I. Okay, dot add I plus 1. Oh, piece of crap. Okay, so last. Let's do last. Last to be this. Oh, it's one element. Okay, it's only one element. It's not total of all the elements. Okay, so you just gotta take track of the highest, right? Oops, okay. So hold on. Let's just undo this. Keep it super simple, right? Okay. So this guy plus equals that guy. Just call it a high, right? High. Or just call it best, right? Best. Best equals maximum of best. A sub I. Best. 2111. That looks good. Big money. Uh-oh. 77. Oh crap. Best is ace of nickel one, last one, right? Okay, oops, I missed that corner case plus one bug. Bug. Oops. It's here. Okay, that looks good. Big money, no whammies. Uh-oh. Oh crap. Okay, so that didn't work. The best is the maximum. Oops, okay. Another corner case I missed. Alrighty. Big money. Okay. Plus two bugs. Whoops. Oh, well. I gave up trying to be perfect a long time ago, and I'm so much more happy not being perfect. And just do my best. Okay. So anyhow, yeah, that works. And that was Q2. Q2 is done with 58 minutes left. 1 hour, 10 minutes, 58 minutes left now. So would that take 12 minutes for implementation? Implementation in Python 3, which is accepted after bunch of tube bugs. Oops. This is a decent solution though. And I just go from right to left. Use solutions. Reduce the input array A from right to left. Checking the maximum total as the best answer. And JavaScript, JavaScript, Python 3, plus C++. Okay. Grab this guy, stick you there. All right, and then to the other languages. Long. Oops. For integers. For integers. Okay. All right, so for no, right, and z.size. It's important as the integer, not u size as well. When we go from right to left, we need the value to be less than 0 in order for the loop to terminate. Okay. Right, so if a sub I plus a sub I plus 1, or it's less than or equal to that then, right? So a sub I plus equals this guy, right? A sub I plus 1. And then best is the maximum itself in this guy. Okay. Whoa. Oh. Long. Yeah, we can cast it to a long. It should be fine, right? Oh, wait, hold on. Oops. Yeah, if this needs to be a long. Okay. Using, the vector of longs. Okay, let's do this. PLA. It's built from this guy. Right, that way I don't have integer overflow when I do that, and that should be okay. Right, 0, no, that's not right. Oh, oops, hold on. I should learn from my previous bugs, right? What I've best is the object and location maximum elements. If I can, that wants to be a lot more, right? That size only be using once, so just cast it here. Okay, something like that. Looks good. That's cool. Alrighty. Kotlin JavaScript. S equals the maximum of a spread. Turn best to the end here, and then let I equals n minus 2. I exceed 0 is equal to 0. If a sub I is less than or equal to a sub I plus 1, then a sub I plus equals a sub I plus 1. Oh, I might need to change these ones into big integers too. Oh, you know what? You just return the maximum of A. We don't need an ephemeral value, right? Spread A. N is not defined. Oh, come on. LeetCode, I'm not going to pay you to hit run code faster. Okay, let's see what happens. All right, that's cool. Oh, you know, I think I can stick this on one liner, which would be cool. Low dash range. Actually, does low dash range work in reverse? I don't know. Reverse. Yeah, we can reverse it, right? Reverse. Map. Giant value. This is true. Then add them together. Otherwise it's 0. Or we just say sub let's see. Let's do this. I plus 1 is less than. Use this twice now. And 0 to n reversed. 5 plus 1 is less than n. And that guy, then it's that, otherwise it's that. And then we'll spread that and return the max. Okay. Uh-oh. Value. Oh. Okay, I see. Map that. Doesn't take into account the previous state. Okay, never mind. This is what we want. This is cool. This is a pretty good solution. So I'm glad that I did in JavaScript in that I can get rid of the ephemeral value best, right? I don't really need that on the spread. Just spread the array. Right, so just get rid of this and return it back here. Slightly best, right? The least amount of code that we write, the better, right? Because there's less chances of bugs. So if you look at the 215's solutions, his are almost always super short and concise. And from my perspective, I believe that's a good sign of intelligence. Right. I strongly believe that simplicity is intelligence, not complexity. Okay, so anyhow, we'll just return this guy at the end. We don't need best. Shorten things up a little bit. This is kind of hard to read. This is better. Looks good. And that I believe is a better solution. Right. So instead of trying to prove ourselves by making clever code, right, we can write code that's super easy to read. And in the end, I believe that's more clever. Okay, anyhow, but what do I know, right? I often don't get the fourth solution during the contest, so just have significant room for improvement as well. Okay, yeah, let's just do this guy right to left. Okay. For in, that's size minus 2 down to 0. Let's do this. Okay, so if a sub I is less than or equal to a sub I plus 1, a sub I plus equals it. Okay, and then return the maximum. Oh, to list. Does to list work? Come on. To to long array. That's what I want. Yeah, that looks good. Okie dokie. Come in. Okay, then we'll do rest last. Turn a dot into iter max. Okay, something like that. Expected. Eh. Oh, actually, I don't need to do this. I can just use the same variable name actually. Expected I64 found. Oh, oops. Rust. Rust is one of those special kind of programming languages you kind of shake your head at. Okay, I mean, that's a decent solution, right? It's okay. Reduce the input array A from right to left, tracking the maximum total is the best answer. Back. All right, I had to go stop one of the timers one of my kids decided to set on their iPad. That just kept going off over and over again. Such good helpers. Okay, even when they're not here, they're helping. Max number of groups with increasing length. And then, okay, so we got Q3 and Q4 coming up. 43 minutes left, and we're on Q3. And Q1 and Q2 are down. Max number of groups with increasing length. Okay. Make 3. 0, 1, and 2. It's 25. Okay, so it looks like greater than the previous group. Okay, so it makes sense to just do greedy, I think, right? Greedy. All right, so make arrays of size 1, 2, 3, dot, 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 right? So we need to pre-process the input, right? Basically, actually, no, we already have the counts. We have the counts we can need. Okay, so here's the counts. Okay, so yeah, it makes sense to greedily consume the values we have the most of first, right? So priority queue, I don't know if I can do that. Priority queue. So if we'll continue extracting, right, there's a continual extraction of the most frequent values. It's the most frequent value will stick here, the most frequent value will stick there, the most frequent value will stick here, right? We have 5 of these 2s. Unique value each. Okay, can we take 3 unique values? 3, top 3 most frequent. It's just, how would we avoid TLE in this case though? 1, 2, right? There should be like a quadratic amount of these things, isn't it? Counts can be big. Quadratic amounts. So how do we be able to count them? Oh, I wonder if we can binary search. Yes. Wonder maybe. Oops. Binary search and make a logarithmic amount of guesses at a cost of what? How much would it cost to validate a guess? Maybe too costly. Remember, we got to keep it super simple. This is just a weird question. Make array subsize 1. I'm concerned about this one. I think it'll work, but with TLE, I don't know. Right? Because each of these things, there could be a billion of each value. And that's, if you consume a billion, right? It would be like way too much. But okay, so seems combinatorics. Greater. Yeah, I don't know. Come back to this one and see what Q4 looks like. We got 36 minutes. Single characters every single edge. 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5. Okay. There's a palindrome ACA. 1 to 5, 2 to 3. Okay, 2 to 3. Oh, it itself doesn't have to be a palindrome, but the count. So the count has to be even for all values except for one odd. 8 of these things. Parent. What does this tree look like? 0 is it parent, so it's just like one flat tree. Is there a tree viewer? Not that there's a way to visualize the tree. Okay, well, you're not. Okay, well, the parent is 0, right? So let's see. It looks like root, and then go like this. Oops, 3. Actually, shift 4. We'll ignore S of 0. So these are all labeled with A. This goes from root is, just call this node 0. Oops. Hard time. Here, okay, 0, and then just be like 1, 2, 3, and 4. Oops. Right. 0, 1, 2, 3, 4. So it's 10. The fifth nodes. UV pass. Yeah. So we knew palindromes, palindromes are identified not by order, just by count. Right. Palindrome, if and only if all counts are even. Oops. Except one odd is allowed. The middle. Okay, so I already have the counts, right? Or no, I don't have the counts. The last problem statement is given the counts. This one, I need to make but there's a quadratic amount of IJ pairs, right? Okay, so this one, I believe, I have a strong feeling, this one is DP. And the reason for that is there's a quadratic amount of UV pairs, right? So we can choose n from the first of the pair and then -1 for the second of each pair. Right, n equals 1e5. So we need a near linear solution for acceptance. Right, so right, how question is like, how else could we perform a quadratic work in a near linear amount of time? We could also pre-process input. Right, pre-process input. Dynamic programming. Man, these two are hard. I'm like, I don't know how to do this one. I don't know how to do that one either. So yeah, usually when I run into these, I think, okay, what would a brute force solution look like? And then can we write a brute force solution and optimize it? Another thing I look at is, let's see, and then that, yeah, I usually just take a break and do a couple Pomodoros, play around with the input on a physical piece of paper. So we've got 28 minutes left. We still have an opportunity to get this one accepted before the 90-minute bell rings, right? So I wonder if we can traverse the tree. Yeah, we definitely have to traverse the tree, right? To look at stuff. Right there. I mean, I guess the order of the nodes matters, but the values can be rearranged, right? So ACAC is, right? ACAC can be turned into ACCA. An even amount over there and an even amount over here. The count, even count per subtree? I don't know, what if we combine the counts of this one? 26 characters. Right, there's only 26 characters. That's all we're counting. A through Z inclusive. If we can do this bottom up post process. Wonder post process. So as the recursive stack unwinds and we perform counts of subtrees. I don't know if that helps or not. Recursive, recursive post-processed traversal tree. Right, go all the way down and come back up. We have 1A doesn't match with anything over here. Or 1A by itself, 1B by itself, 1C by itself. Okay, that counts as one. Or we can add them all up at the end as singles. No, I don't know, man. Huh. Something tells me this is going to be a 2. A 2 out of 4. 3 minutes. This only took 12 extra minutes. Oh, I wrote those in the other languages. Okay. Oh, that's awesome, man. These guys did this in like 20 minutes. This dude's cool. I like this guy. It's really legit dude. This guy's legit too. Oh, this guy hasn't solved it yet. Huh. Well, let's see how much time is left in the contest. 25 minutes left in the contest. Man, this is a tricky one. Not very many people got the Q3. It's awesome. Everyone that did get it besides this dude. This guy's cool too. 5 minutes. That's super cool. Yeah, so I've observed that in order to actually solve these, for the most part, we have to pretty much know them, right? Know the algorithm. We can't just like figure out so much on the fly. And there's some tricks to the trade, especially with this one. I think there's like a tricky dynamic programming in that if we go to the left, right? So if we have absolute offsets, right? Here's the absolute counts from the root's perspective. When we go to the left, then that root has the counts of the left subtree minus that one over there. Yeah, I don't know. I have to play around with the input to kind of see what solutions there are. So, yeah, I mean, here's the deal, right? Here's the deal. When we first read a problem statement, the search space for valid solutions is near infinite, right? And then we, I guess, iteratively reduce the search space based upon right feasibility. Right? Like, will this even work within the round of time that we have, right? So we know we have a quadratic amount of pairs to consider. And traversing all those pairs would be more than quadratic, actually be cubic, right? That we're going to traverse and consider all of those, right? To make all these kind of like pairs down the tree. It's almost like taking a cubic amount of brute force solution into a linear solution. It looks like quite a few folks have solved Q4. Folks have figured it out, right? Oops, only a couple. Right, and yeah. Oh, interesting. Some of the top folks haven't solved Q3, but these folks have. This guy's cool. Larry from New York. Okay. Anyhow, yeah, usually I don't solve these ones during contest. So not unexpected to miss it. Add it to my unsolved bucket. Yeah, I'm not really seeing how to solve this one, right? So we know their palindromes are identified by count for the pass. So if it is DP, the key question is, and what is the recurrence relation? Right, what are the states? What are the states? What is the current recurrence relation between those states? wonder if we can use inversion too, right? Inversion? If we count the opposite. This guy. 0, 1, 2, 3, 4. All right, so it's length 5. 5 minus 4 divided by our times 2. All right, 20 divided by 2 is 10. 5 times 4. Just like n times n minus 1 divided by 2, where n is 5. Dude. Two palindromes of length. Three, one palindrome of length 4. All right, I'm totally stuck on these two. So usually the best thing I can do when I get totally stuck is just take a break. And honestly, I'm not much of a competitor in the contest anyhow. I don't solve all the problems in a timely manner. So I think it makes sense to just go slow. That's what I've been doing, right? It goes somewhere slow or nowhere fast in this life, and it's easier to go nowhere fast, right? Just I could just look at someone else's solution, right? But yeah, I don't want to be a boat anchor. Right. Okay. So I'm gonna call it a day. Right. I've been just like sitting here staring at this thing, not making progress. So this is about where I'm gonna land, somewhere around here. Okay. Let's call it a day. And then I'm gonna go start doing some other work here. 25th. Okay, this is contest 355 to be continued to upsolve Q3 and Q4. Okay, I'll catch y'all later.